Jerome Loayon.
And I am Jancel Mallorca.
Paul Vincent Monserrate.
I'm Jonathan Okulang.
I'm Samuel Larita.
I am Jerwin Padillo.
And I am Kyle Vincent Palacat.
We are the Group 4 from BSCE 1C.
And this is Mathematics in the Modern World.
And today, we'll be tackling measures of positions, quartiles, decimals, and percentiles for group data. First, we'll present to you the objectives for today's discussion.
Our objectives for today, which are number 1, to illustrate the following measures of position, quartiles, deciles, and percentiles. Number 2 is to calculate the specified measure of position of a set of data.
Now, let's move to the main part of our discussion and try to achieve the aforementioned objectives. For our main presenters, you'll have Kyle, Jerwin, and me. I'm today's first presenter, and I'll explain to you what quartile is.
Now, what does a quartile mean? Quartiles are three values that split sorted data into four parts, each with an equal number of observations. The word is somewhat similar to quarter, which means that there are four equally divided parts. Quartiles are a type of quantile. First quartile, also known as Q1 or the lower quartile. Second quartile, also known as Q2 or the median. Third quartile, also known as Q3 or the upper quartile. So here's the formula used in finding the quartile of group data, where Q is quartile, LB is lower boundary of the QK class, N is total frequency, CFB is equals to cumulative frequency of the class before the QK class, FQK is frequency of the QK class, I is size of class interval or class width or the interval, K is nth quartile where n is equals to 1, 2, and 3. So this formula is read as Q sub k, where k is to be given. Say for example, you are asked to find the second quartile. Then it is read as Q2 is equals to LB plus the quantity of 2 and the frequency, the total frequency, over 4 and minus CFB or the cumulative frequency of the class before the Q2 class over the frequency of the Q2 class times the size of the class interval.
Now, let us try and compute the following. A. Q2 or the second quartile. B. Q3 or the third quartile. So before doing anything else, let us first complete the frequency distribution table. So as we can see here, there's the column for lower boundary and the less than cumulative frequency is still empty. So let's fill this up. To get the lower boundary, we will have to subtract the lower class by 0.5. So 20 minus 0.5 is 19.5. 30 minus 0.5 is 29.5. 40 minus 0.5 is 39.5. 50 times minus 0.5 is 49.5. 60 minus 0.5 is 59.5. And 70 minus 0.5 is 69.5. And to get the less than cumulative frequency, we will just have to add 5 by the second frequency and so on. So 5 plus 7 is 12. 12 plus 10 is 22. 22 plus 8 is 30. 30 plus 6 is 36. And 36 plus 4 is 40. Now that the frequency distribution table is complete, let us proceed to identifying the following. So let's identify first the second quartile. So as we can see, we have to identify first the important values to identify the second quartile. So as we can see here, K is already given by the Q2. To find the N, or the total frequency, we will have to add all the frequencies to get it. So N is equals to 5 plus 7 is 12, 12 plus 10 is 22, 22 plus 8 is 30, 30 plus 6 is 36, and 36 plus 4 is 40. So our total frequency is 40. So let's put 40 here. And next, we will have to do this first, the Kn over 4. It is to identify to which class the second quartile belongs. So Q2 is Kn over 4, where K is 2 and N is 40, divided by 4 equals to 20. So we got 20. So what will we do next? We will have to base here and find what class Q2 belongs. So as we can see in 5, it cannot cater 20. In 12, it cannot cater 20 as well. So in 22, it can already cater 20. So the second quartile is in this class. So it's in this class. We can already identify the CFB, the FCK, and the lower boundary, and also I. So let's look at here, focus here for the second quartile. So the CFB is the cumulative frequency before the class. So the cumulative frequency before the class is 12, which is here. You have to base here, and before it is 12. So 12. So the frequency of the class is 10. The lower boundary of the class is 39.5. To get the I, we will have to subtract the second lower class by the first lower class. So 30 minus 20 equals to 10. So we will get 10 here. Now let us substitute the values to the formula. So Q2 is equals to 39.5, the lower boundary, plus the quantity of Kn over 4, which is 20, minus the CFB, or the cumulative frequency before the class, which is 12, over the frequency of the class, which is 10, times the interval, which is 10 as well. So let's calculate it using the calculator. So 39.5 plus the quantity of 20 minus 12 over 10 times 10. So we will get 47.5. So the second quartile is 47.5. And let us move to the second problem, where we will have to identify the third quartile. So it is simple. We will just have to follow the procedure of the previous problem. So N is 40, and we will have to identify also the important values. So FCK, LB, and I. So I is still the same in here, since we will still just use this frequency table. So I is 10, and we will have to identify where the class belongs. So Q3 is equals to K, which is 3, N is still 40 over 4. So we will get 30. So 30 belongs to here. So we will just focus on this row. So the cumulative frequency before the class is 22. The frequency of the class is 8. The lower boundary is 49.5. So we will have to substitute it to the formula, which is Q3 is equals to 49.5 plus the quantity of Qn over 4 is 30 plus the cumulative frequency, which is 22, and the frequency, which is 8 times 10. Let's use again the calculator. So we have a mistake. This is a minus. So we will get 59.5. So the third quartile is 59.5. So that's how we will get the quartile of a given data.
Next is deciles. Deciles are measure of position calculated on a set of data. The deciles are the values that separate a distribution into 10 equal parts, where each part contains the same number of observations. The decile is a member of the wider family of quantiles. So to solve for decile, this is the formula, where D is the decile, LB is the lower boundary, N is the total frequency, CFB is the cumulative frequency of the class before the QK class, and F is the frequency of the class, and I is the interval of the class, and K is the nth decile, where N is 1, 2, 3, until 9. So for example, in this given data, solve for the following. So here we have a problem that we got to find the D3 in this given table. So first things first, before going to find the D3, we got to find first what is N. So to find N, we have just to add all the frequencies. So our frequencies are 5, 7, 10, 8, 6, and 4. So adding all these frequencies, the result is 40. So N is 40. Next, we got to find our cumulative frequency before. So to find this, we got to add the first frequency to the second frequency and go on. So our first frequency is 5. So 5 plus 7 is 12. 12 plus 10 is 22. 22 plus 8 is 30. 30 plus 6 is 36, and 36 plus 4 is 40. So now we have our frequency, our N, and our cumulative frequency before. So next is we got to find what is D3. So to find D3, the formula is D3 is equal to lower boundary plus kn over 10 minus cumulative frequency before over f, then multiply it by interval. So first is we got to find what is the q key class of D3. So to simply find it, of D3 is kn over 10, where k is 3, since the we defined is D3, so our key is 3. So 3, then our n is 40 over 10. So the answer here is 120 over 10, or equal to 12. So this is our q key class. So we got to find where in the table does it belong. So here it is 1 to 5, then here it is 6 to 12. So this here is where D3 belongs. So after, we can simply find missing elements. So we have now our key n over 10, our lower boundary, which is 30 minus 0.5. So our lower boundary is equal to 29.5. Then our cumulative frequency before is equal to, since this is where our q key class is, so 5 is our cumulative frequency before, so it is 5. Then our frequency is 7. And lastly, our interval. So to find the interval, you just have to minus the two class interval. So 30 minus 20 is equal to 10. So here 10. So with that, we can simply solve. Our lower boundary is 29.5 plus our key n over 10, which is 12. Then cumulative frequency before is 5 over our frequency, which is equal to 7, times interval 10. So it is 29.5 plus 10, since 7 over 7 is 1, then multiply by 10, so 10. So our D3 is 39.5. That is our D3.
Good day everyone, I am Calvin Palakat and reporting the topic percentile. So, out from the three topics, the decile, quartile, the percentile is the third, which means are the 99 values for the variable that divide an ordered data set into 100 equal parts. So from the name itself, percentiles, percent, so the maximum number for percent is 100%. Regarding percentile, it is 100. Unlike quartile, which is quarter, which means 4, decile, which is 10, percentile is 100. The percentile determines the value for 1%, 2%, up to 99% of the data. So, the formula used in finding the percentile of a group data is PK. So PK is given. Depending on the given, or to where the data the data is to be found, equals LB, which means lower boundary of the QK class, then Kn over 100, K is given, and n is the total frequency. So it is divided into 100 since percentile is 100. Unlike quartile is to quarter and decile is to 10. Minus cumulative frequency of the class before the QK class over the frequency of the QK class times the size of the interval. So below, where P means percentile, LB is lower boundary of the QK class, N means total frequency, CFB means cumulative frequency of the class before the QK class, and FPK means frequency of the QK class. I means size of class interval, in K means the end percentile where N is 1 to 100. So out from those three, quartile, decile, percentile, there is also a formula when we are to find the percentile of the ungrouped data. So the ungrouped data formula for percentile is Pk is equals to K over 100 times N plus 1. So we note that D1, D2, and D3 corresponds to, respectively, T10, T20, T30. And Q1, Q2, Q3 corresponds to 25, 50, and 75. So D means deciles, which is 10. So 100 divided by 10 is equals to 10. And quartile is to quarter, which is 4. So 100 divided by 4 is 25. So P10, P20, P34 deciles, and P25, which is the 1/4 of 100 in quartile. So let's have an example using percentile in group data.
So let's have an example in percentile. So this is the given. And let's find P70. So percentile 70. So first, we need to complete the table. So in completing the table, class interval is given 10 frequency. So the class boundary may not be given or it may be. So in getting the class boundary, we will add 0.5 on the second interval and subtract the first interval by 0.5. So 20 minus 0.5 is 19.5. 29 plus 0.5 is 29.5, and so on and so forth until we reach 79.5. So 29.5, 39.5, 39.5, 49.5, 49.5, 59.5, 59.5, 69.5. Then 69.5 to 79.5. It depends on the given. So now, let's find the cumulative frequency. So in getting the cumulative frequency, we first copy the first row. So 5. Then add it with the second row. So 5 plus 7 is equals to 12. Then next is add it to the third. So this and that. So 12 plus 10 is equals to 22. Then repeat it. 22 plus 8 is equals to 30. 30 plus 6 is equals to 36. 36 plus 4 is equals to 40. So now, let's recall the formula for percentile. So, the formula for percentile is PK is equals to lower boundary plus KN over 100. Since it is percentile, so it should be 100 over cumulative frequency before the percentile class over frequency of the percentile class, then multiplied by the class interval. So the next thing to do, since we have completed the table, we will now get the values in this formula. So PK is given, since PK is P70. So PK is PK is equals to P70. So K is equals to 70. Then, first thing we need to do is find the class row. So P70 is equals to, so what is the K? So K is 70. So what is our N? The N is the total number of frequency. So the total number of frequency is 5 plus 7 is equals to 12. 12 plus 10 is equals to 22. Then 22 plus 8 is equals to 30. Then 30 plus 6 equals 36. Then 36 plus 4 is equals to 40. So our N is 40. So N is 40 over 100. So our class row is 2,800 over 100. So it will be 28. So our class row should be either 22 or 30. So in this row or in this row. So the closest cumulative frequency. So it should be 22 or 30. But the number closest to 28 is 30, since 30, the gap between 30 and 28 is only 2, while the gap of 22 and 28 is 6. So it has lesser gap. So the P70 is at the fourth row, which is having the cumulative frequency of 30. So now we will find the lower boundary. So if we can get the row, we can now find the other values in solving for P70. So LB, so lower boundary, it will be found in the class boundary, since lower boundary, class boundary. So the lowest boundary, so it is 49.5. 49.5. Then next is the cumulative frequency before the percentile class. So before the percentile class. So what is before 30? It is 22. So CF before the percentile class is 22. Then let's find the frequency. So the frequency is given here. So it is 8. Then the class interval. Getting the class interval is subtracting the lowest class interval of the second row by the lowest interval of the first row. So 30 minus 20 is equals to 10. So now we can solve for P70. So P70 is solved because all the values are now given. So let's proceed to the formula. Let's substitute all this in the formula. So P70 is equals to lower boundary. So lower boundary is 49.5. Then the class row, which is Kn over 100, is 28. Then the cumulative frequency before the percentile class is 22 over the frequency 8. Then it is multiplied by the class interval 10. So now we can solve for P70. So using your calculator, P70 49.5 plus 28 minus 22 is 6 over 8 times 10. So using your scientific calculator, P70 is equal to 57. So 57 belongs in the class interval of 50 to 59. So P70 is equal to 57. It belongs to the class interval 50 to 59. So that's it for percentile for group data.